Okay, I'm going to do a quick little PowerPoint just so that your homework may be a little more clear. All right, there are a couple things when I went back and looked at the way that the directions are worded, I don't want to get you confused, okay? So this will take just like 10 minutes. It shouldn't take long. So let's go ahead. Let's see if I can find, let's see what we want to do. Okay, let's see if I can pull it up. All right, here we go. We're going to talk about solutions to equations. Now, let me make sure we're clear about something. If they talk about a solution to an equation, they're asking you what numbers make the sentence true. So if a number makes it true, it's a solution. If it doesn't make it true, it's not a solution. So it says, thus, to determine if a number is a solution, substitute that number into the equation. If the resulting equation is true, then the substituted number, the number that you plugged in, is a solution. Okay? If the resulting equation is false, then the substituted number, the number that you substituted in or plugged in, is not a solution. Okay, so look up here. Okay, you get a pointer. All right, 2x plus 3 equals 13. Is x equals 1 a solution? So I'm going to replace that x right there with a 1. Okay, soon enough. 2 times 1 plus 3. Well, 2 times 1 is 2, and 2 plus 3 is 5, and 5 does not equal 13. That's not true. So x equals 1, that's the number that I substituted in, is not a solution. All right, is x equals 5 a solution to this equation? Well, take out x and put in 5. So 2 times 5 is 10, and 10 plus 3 is 13. See, 13 equals 13 is true. So the number that you plugged in, that x equals 5, is a solution. So when they ask you if numbers are solutions, substitute them in. If the resulting equation is true, the number that you plugged in is a solution. If it's not true, it's not. And then I put a little note down here, make sure we're clear. Sometimes equations have just one right answer, one solution. Sometimes they have multiple right answers. Okay, you may get one answer or 22 answers or 3 answers or 4 answers. Sometimes they don't have any answers. So there's nothing that you can substitute in that'll make it true. So they have no solution. And sometimes they may have all numbers or solutions. Okay, so let's clear this and go look at some examples. All right, look at this next one. Example 2, 4 times x minus 6. All right, distributive property of multiplication over subtraction. So 4 times x, where I got the 4x and then minus, and then 4 times 6 is 24, equals 2x plus 8. Now, I'm going to put the variables on this side, that's just me, and the numbers on this side. Sometimes I'll write myself a note so I don't get lost. Now, if you'd rather put the variables on the right and the numbers on the left, that's just as correct. It's just a personal preference. I'll kind of do it both ways, so you can kind of watch later. Well, I want to get the variables over here, so I've got to get rid of that minus 24. Now, what undoes subtraction? Addition. But if you add 24 to this side, remember you got to add 24 to that side. So that's why the 24s go out and leave me 4x. And then there's my 2x. Well, 8 plus 24 is 32. So now I've got variables over here. Well, I want numbers over here, so I've got to get rid of the 2x. So how do I get rid of that 2x? Well, I subtracted 2x from this side, so I had to subtract 2x from that side. Well, 4x minus 2x is 2x, and then the 2x's go out here. 2x minus 2x is 0, so it'll be the 32. Now, I did this to show you something. I made a careless error. 2x divided by 2x is x, but 32 divided by 2 is not 6, it's 16. Okay, but what if I made a mistake and put 6? If I substitute back up here, 6 minus 6 is 0, and 4 times 0 would be 0. But this side won't be 0, so I know I've made a mistake, so I go back and double check. Wait a minute, 32 divided by 2 isn't 6, it's 16. And if you do 16 minus 6, isn't that 10? And 4 times 10 is 40. Okay, and up here, 2 times 16 is 32, and 32 plus my 8 is 40. So see, when I substituted 16 back up here, I got a true sentence. So that's how I know that 16 is right. So I've got one right answer to this one, and it's 16. All right, look at this one. 3 minus x equals 4x minus 5x. Now, these are already alike, so I went ahead and combined them. All right, so I've got, so I'm going to put, I think I'm going to put variables over here this time, and numbers over here, just to show you that it doesn't really matter which side you put them on, but just decide and then stick with it. Well, I've got a negative x, 4x minus 5x is a negative x. So if I want variables over here, I got to get rid of that minus x. Well, how do you undo subtraction? You add. But if you add x to this side, you got to add x to that side. So here I get 3x minus 0 just stays 3. Well, the negative x plus x is 0. So this says 3 equals 0. Well, when does 3 equal 0? 3 doesn't ever equal 0. So what does that mean? That statement's false. When you get a statement that's false, that means there's no answer. So this would have no solution. There's no number that you can substitute in for x and make this to be a true sentence. Okay? So that's an example where we got one solution and then we got no solutions. All right, let's go look at another one to make sure we kind of have all of our bases covered. Look at this one. Let's solve this one. Now again, I don't care. Suppose I decided to go back and put variables on this side, and I decide to put numbers on this side, whichever way you want to do it. So I do distributive property of multiplication over subtraction. Well, 4 times x is 4x, and there's my minus, and then 4 times 2 is 8. And then over here I do 2 times x, that's where I got my 2x, and then minus, and then 2 times 4 is my 8. Okay, well, x plus 4x is 5x. And then over here, 3x plus 2x is 5x. Now, some of you could stop right here and know what to write. I didn't notice, so I kept going. Okay, isn't 5x minus 8 always going to equal 5x minus 8? Isn't always going to equal itself? Okay, but if I want variables over here, if I get rid of the minus 8, so I added 8 to this side and I added 8 to that side. So the 8's went out over here and left 5x, and the 8's went out over here and left 5x. So again, if I want variables over here, I've got to get rid of this 5x. So I subtracted 5x over here, so I had to subtract 5x over there. Well, I get 0 equals 0. Now, what does that mean? When does 0 equal 0? 0 always equals 0. So this thing is always going to be true. So what does that mean? That means all of the numbers work. If you let x be 0, it's going to work. If you let x be 4, it's going to work. If you let x be a negative 3, it's going to, all numbers work. Dot, dot, you know, all the numbers are going to work. So if all the numbers work, say all real numbers, any number will work. You can put any number. Now, sometimes the back of the book will put all real numbers, and sometimes the back of the book will put infinitely many solutions. Those are just two ways of saying the same thing. Remember, infinitely many means too many to count. Okay? I'm going to put all real numbers. But notice the back of the book may put this sometimes and that sometimes. Okay? Hopefully that'll make your homework go just a little more smoothly. So if you need some help, just contact me. Okay? So go to Moodle and work your homework, and then let me know if you have any questions. Okay? All right, see you in class.